Welcome to Chemistry Wide. Today we will see fundamental concept of the quantum theory or quantum mechanics. See the first quantum mechanics is a theoretical part of the chemistry. Next, quantum mechanics is not a experimental, it is required more concept in mathematical. Next, basic function or wave function, it is denoted as psi symbol. See the symbol psi. Symbol psi, it is indicated wave function. There is no physical meaning for psi. Next, quantum mechanics mainly focusing wave character of electrons. Next, in quantum mechanics, the word of the system, it is denoted electrons only, not other things. Please here listen here, a system means electrons. Please you should keep in mind. Next, we know that electron has dual character in nature. It is discovered by de Broglie. Next, the propagation or spreading. Propagation means spreading. Spreading the electrons as particle forms and wave forms. See the dual character. This is dividing two forms. First one particle and wave. So de Broglie given the equation for as lambda equal h upon p. Here lambda is wavelength and h is the Planck constant and p is the potential energy. Next, we know that particles forms of the electron going to straight direction, one place to another place, but wave forms of the electron going to like zigzag, one place to another place. See here below. This is the particle form of the electron. For example, copper wire or silver, like this. We will see at waveforms the direction is like zigzag. See here, this is the waveform, this is the particle form. See, if electrons moving at waveforms, that is called a wave function. It is denoted symbol psi. This is the mathematical symbols. Here psi gives more mathematical information about the waveforms of the electrons. Here psi is the modulus form. There is does not any negative values. If comes any negative values, we should changes the positive. Please keep it in mind. size the modulus form. We should size the at modulus form. Next, all waveform electrons, we can't say exact position of the electron distribution. So we can say like this is probability distribution of the electron. It is denoted between the two region. See below. Size the probability distribution. Probability means electrons at particular region or boundary where they are found. For example, if we take boundary or region A and B at x direction, see here, this is the A region, this is the B region or boundary at x direction. See below, here electrons found within the A and B boundary, not crossing the out of the boundary. Next, we know that if we take integration, we should give the limits, because electrons probability distribution within the boundary condition and it is finite. We should not give infinite like negative and positive value, because it is denoted there is no limitation or unlimited. Next, if we take wave function psi, we can give 3 axes below. See, so we can give 3 axes like this. So psi equal to x, y, z respect with time. T is denoted time. See below. According to Einstein relativity theory, all objects depend on the time in the universe. So time is also called fourth dimension. We can say time is also called fourth dimension. Here wave function psi or probability of the electron distribution at x, y, z direction, it is depends on the time. This direction is depend on the time. So be careful. So psi equal to at x, y, z direction with respect to time. We know that at mathematics, when we put the graph below, see, this is x, y, z. When we put the graph, here is positive x, here is negative x. This is the minus x slope, this is the positive x slope. This minus is complex conjugate values. This minus x is the complex conjugate value of the plus x. See below. Plus x value is complex conjugate value of the minus x, or we can say like this. If we take plus x values x, y, z, t, so psi equal x, y, z, t. If we take minus x values x, y, z, t, so here, see here, we should give star, and we did not give or does not give minus I. See, this is the conjugate value psi star. So psi star equal x, y, z, t. Here don't put minus sign, negative sign. Finally, we can say below plus x is psi equal to x y z t minus x is psi star equal to x y z t. Suppose if we take at y direction, see below, this is the y direction, this slope is plus y, this slope is minus y, this is the this minus is the complex conjugate value, see below. So plus y equal gives psi equal to x y z t minus y gives psi star equal to x y z t. This is the conjugate value. Same thing here, if we take at z direction, see here, this is the z positive, this is the z negative, this is the conjugate value here. So plus z gives psi equal to x y z t minus or negative z gives psi star equal to x y z t. This is the conjugate value for this. Here if we take x y z t value is equal to a plus ib, see below, psi x y z t equal a plus ib. Here a and b real value of the wave function. When psi values at x y z direction, when changes depend on the time, we get one real value. That real value is equal to a plus ib. See below, we know that I value is equal to root of minus 1. So we can write below, see, this is the both are real value, psi equal to root of minus 1. If we take complex conjugate negative slope, we can write psi star x y z t equal to a minus ib. This is the ib, not my negative side. This is the not positive because we taken for psi star or conjugate value. This is conjugate form of the equation. This is the conjugate form. Above, see the above form is normal form. Please 1 minute. This is the normal form. This is the conjugate form for x only. This is conjugate form of the equation. Now we get two forms. See, psi x y z t equal to a plus ib, psi star x y z t equal to a minus ib. Here distribution of the electron should be at 6 axis. For see here, this is the 6 axis. Each axis has 2 sign, plus x minus x plus y minus y plus z minus z, totally 6 distribution axis. Now we can multiply both values. See below, psi star x y z t equal to a plus ib, a minus ib. So we get psi star x y z t, this value should be going to modulus form. See, so I equal to root minus 1. When square I and take the square for I, we get minus 1. When we take the square for I, when we take the square for I, we get minus 1. So I square equal minus 1. See, now after multiplying psi star x y z modulus form equal to a square minus b square. See, a square minus b square minus 1, we get a square plus b square. Finally we get psi square x y z t equal to a square b square. This equation called probability density of the electron. See below carefully. Psi tells us about the electron distribution between the A and B boundary region only. Psi tells about the only electron distribution between the A and B. Psi distribution within the A-B boundary. But modulus of psi square tells us the probability of the finding electron or electron density. It may be at boundary condition between A, B. Here this place may be 30%, this place may be 25% probability or density. Here 15%, here 20, here 40%. Anyway, like this. This is the probability or density of the electron. This boundary is the, please keep it in mind, this boundary is the size tells us this distribution of the electron, but psi square tells us the maximum probability finding the electron. Please keep it in mind. See, the percentage values denoted maximum probability finding the electrons or minimum probability finding the electrons. So psi gives electron distribution. So A gives B. Psi star electron probability. This is the electron distribution. This is the psi star is the electron probability. Please keep it in mind in both. And the two boundary condition, between the two boundary region or condition. Next, limitation of the wave function psi. See, psi should be finite value at x, y, z direction. Second, it should be single value of at x, y direction, not a multiple value. Third one, it should be continuous in all boundary region at x, y, z direction. Please note, Please note here, when comes the potential energy V, it is going to finite value to infinite value. Here this continues or this continuity of the electrons will be cut or break in this condition only. Please remember this. When comes the potential energy V, when if we give any potential energy, it is going finite value to infinite value. Here this continuous will be break. Only here this continuous will be cut or break in this condition. What condition? When we give the any potential energy. Next, we know that psi values changes x, y, z direction. Here we can give one operator for all for x, y, z direction. So we can represent, we can write below tau psi upon tau x, the tau psi upon tau y, and tau psi upon tau z. Here tau is the operator. Here all as one operator. Please subscribe the channel. More videos on the way. Weekends, the continuity of the discontinuity of the topic we can see next video. Please subscribe the channel and support me. I am making more videos for chemistry and physics. Thanking you all.